The word propulsion comes from the Latin propulsus, which is the past participle of the verb propellere, meaning to drive away. In a broad sense, propulsion is the act of changing the motion of a body. Propulsion mechanisms provide a force that moves bodies that are initially at rest, changes a velocity, or overcomes retarding forces when a body is propelled through a medium. Jet propulsion is a means of locomotion whereby a reaction force is imparted to a device by the momentum of ejected matter. Rocket propulsion is a class of jet propulsion that produces thrust by ejecting matter stored in a flying vehicle called the propellant. Duct propulsion is a class of jet propulsion and includes turbojets and ramjets. These engines are also commonly called air-breathing engines. Duct propulsion devices utilize mostly the surrounding medium as the working fluid, together with some vehicle-stored fuel. Combinations of rockets and duct propulsion devices can be attractive for some narrow applications, and one is briefly described in this chapter. The energy source most useful to rocket propulsion is chemical combustion. Energy can also be supplied by solar radiation and, in the past, also by nuclear reaction. Accordingly, the various propulsion devices can be divided into chem-ical propulsion, nuclear propulsion, and solar propulsion. Table 1.1 lists many of the important propulsion concepts according to their energy source and type of propellant or working fluid. Radiation energy can originate from sources other than the sun and theoretically can cover the transmission of energy by microwave and laser beams, electromagnetic waves, and electrons, protons, and other particle beams from a transmitter to a flying receiver. Nuclear energy is associated with the transformations of atomic particles within the nucleus of atoms and usually is created by fission or fusion. Other energy sources, both internal, in the vehicle, and external, can be considered. The energy form found in the output